All right, so the next unit we're going to be talking about, or the next set of slides, I guess I should say, is empirical formulas, and it sounds kind of crazy, empirical formulas, but it's really pretty straightforward stuff. It's basically, an empirical formula is the simplest whole number ratio of elements in a compound. The simplest whole number ratio of all those elements in a compound. So say, for example, you have C6H12O6, and of course we know C6H12O6 is glucose. Notice, and again, it's probably a little difficult to see that, but basically we have a 6 to 12 to 6 ratio. All right, 6 to 12 to 6 ratio, and again, you're just looking at the subscripts. You can simplify that to 1 to 2 to 1, right? If I divide all of them by the smallest, in this case it's 6, then I can get my simplest whole number ratio. Notice it is a whole number, 1 to 2 to 1. So the empirical formula for glucose is CH2O. That's the empirical formula. It's as simple as that. Okay? So if I have something like, let's say in this case, water as a molecular formula, its empirical formula would be the same, right? Because it's a 2 to 1 ratio. Empirical formula is just simply the simplest whole number ratio of elements in a compound. In this case, glucose can be simplified down to 1 to 2 to 1, or CH2O. Water, for example, can't be simplified any further, so its empirical formula is also H2O. All right, that's an empirical formula, straightforward enough. Now what we're going to do is, let me just talk a little bit about how we can kind of get into determining those, etc. All right, first, important to know is percent composition. Percent composition just simply is a part over total. If I wanted to say in my classroom here at TRAPE, I wanted to know what the percent composition of guys in a class versus girls in a class. Notice if I had a class that I had 10 total, oops, let me just erase that and kind of point towards it. 10 as my total, and I had 7 guys and 3 girls, then simply would be this part 7 over the total amount of students, or the part 3 over the total number of students, 10, and you just simply divide those two and multiply by 100 since it's percent composition, and you get 70% fellas and 30% ladies. Okay, so percent composition is just simply the part over the whole, okay, or part over the total. Now we can do percent composition for compounds as well. If I want to know the percent composition by mass of elements in a compound, let's take a look at it. H2O. H2O is water, and it has a total mass of 18 grams. Of course, that's 18 grams per mole, but again, 18 grams is H2O. The percent composition by mass of that H and O are this. Notice the mass of the H's is 2. The mass of the O's is 16. That's how I would get my 18. And so I just take the part, the 2, over the total, 18, multiply by 100, I get my 11%. Same thing for the oxygen. So even though I have only 1 oxygen and 2 hydrogens, I have a lot higher percentage oxygen than I do hydrogen because it's much more massive. So if I want to know my percent composition by mass of elements in a compound, you take the mass of each of the ones, and again, if you have more than one, you would multiply by that factor, and take that over the total. So I think I have another one, and you might not be able to see this too well with my little picture-in-picture, but basically, here's ammonium sulfate. Ammonium sulfate is NH4,2SO4, and its total mass is 132 grams, 132 grams per mole. So if I want to determine my percent composition by mass of each of them, notice nitrogen is 14 off the periodic table, but I have 2 of them. I hope we all know that the subscript 2 here distributes to both because it has a parentheses. So I'd have 28. Okay. Hydrogen, well, hydrogen is 1, and I have 8 of them, because again, that 2 distributes, so that's 8. Sulfur is 32, and I only have 1 of them. And oxygen is 16, but I have 4 of them, so that's 64. So if I add all of these numbers up, I get that 132. And simply notice here I've taken the part of each of them, the part of nitrogen, hydrogen, sulfur, and oxygen, and divided it by the 132, and I get my percentages, which are 21% nitrogen, 6% hydrogen, 24% sulfur, and 49% oxygen. Now, I hope that we all recognize that in both these cases, our percentages always add up to 100% or 100, okay? So if I wanted to, if I solved for, let's say, hydrogen in this case, and I got 11, I could just simply subtract from 100 to get that 89% oxygen by mass. So that's percent composition, and that's the initial stages of empirical formulas. The next slides, we're going to get into a little bit more details on how to determine empirical formulas.